Now on to question 3. Question 3 is the last 10-point question in the AP FRQ test section. 1, 2, and 3 are worth 10 points, and questions 4, 5, 6, and 7 will be worth 4 points each. So we've got quite a few points that we can mine out of this. So here we've got 3 pages, A, B, C, and D, to come up with a lot of points. Let's get to the first one. A. Here we've got a reaction of tetrafluoroboric acid is being produced. That's a strong acid. It's one of the ones that you don't have to memorize. It's really exotic. And they show it ionized here because it's a strong acid. The acid can be prepared by reacting the weak acid. So we start with a weak acid, H3BO3 boric acid. They give us its molar mass, and it's reacting with a gas according to the equation above. To prepare a solution of our super strong acid, HF is bubbled into a solution containing 50 grams of boric acid in a 1 liter vessel. Let's take a quick aside because boric acid is one of my favorite weak acids. Here it is, a boron with 3 oxygens around it. That's what you expect because it's one of our Lewis dot diagram substances that only needs an octet around it. And then we've got H's and H's giving us 3 hydrogens. It's a white powder at room temperature. It can be found almost in any hardware store. Common name is boric acid. It's an antiseptic. In solutions, it can be used to kill bacteria and fungi. It's an excellent insecticide. In fact, it's actually the first registered insecticide. It's still used a lot. Relatively safe, flame retardant. Also, it can be used as a wood preservative. It's a powder that's pretty soluble, and it's interesting. You can read about it. It even is involved in as a pH buffer. So boric acid, if you have some time, read it over, and as I say, it's used pretty. But let's get back to the problem because we've got 10 points to get. So here's the question. Calculate the maximum number of moles of BF4-. Okay, here's the stuff, BF4-, that can be produced. Okay, we've got a reaction. It's a 100% reaction, and we use our boric acid to make it. Now, they gave us 50 grams of boric acid. Well, we've got a mass, we've got a formula, and they even give us the molar mass. We can do some quick calculation. So we can just do this calculation of changing grams into moles. That got 50 grams of a substance. Yeah, I'm sure we've got to change the grams into moles, divide by the molar mass. I'll pull out my calculator, and we'll take that 50 and naturally divide by the 61.83. Now, show this on your notebook. You want to show them that you can calculate moles, and there's our answer. I'd carry it to only 3 significant digits. A simple question like this sometimes is used for their sig fig point. So I would definitely say 0.809, 3 significant figures, and indeed that's the answer. Show the calculation. Anything that you put in your calculator, write down, because if you just wrote down 0.809, then they'll say, no, I didn't get that. Forget it. You don't get the point, even though you did it right. But don't forget, this is the number of moles of BF4-. Well, let's see. 1 boric acid produces 1 of this boron tetrafluoride anion. So we just have to say it's a 1-to-1 ratio. You can just say 1-to-1, and there's our answer, 0.809. There's no coefficients. It's a surprisingly easy point if you know how to change grams into moles. And like I said, I'd be really wary of making sure you have the right number of sig figs in a simple problem like this. On several AP exams, this was what they used for the sig fig point. The others were lab things. Before going on to II, let's double check. Did we answer the question? Calculate the maximum number of moles of BF4-. Yep, we've got that written down, so we've answered the question. But also, does it make sense? Well, let's see. If we had 50 grams and the molar mass is 61, we'd expect, pretty close to 0.8, 0.9 moles. And it's a 1-to-1 ratio, so the answer makes sense, and we answered the question. Next, calculate the number of liters, not moles, liters of HF gas. Okay, a volume of a gas. Okay, PV equals nRT, gas laws. But measured at 273 K, so we got a temperature. We've got we'll figure out moles somehow, and we've got a pressure that will be consumed if all the boric acid reacts. Okay, here's the boric acid reacting. 1 boric acid makes 4 HF gases. So we've got a molar ratio. We can probably get a point just for that. In fact, I bet that when they do this scoring, they'll say, okay, 1 point for figuring out the moles of gas, because you need that to find the liters. And indeed, you'd say, we'll take our moles of boric acid that we calculated before and do a 4-to-1 stoichiometry. It's a stoichiometry problem that they're going to give you some points for. Calculator, we still have our 0.080 there. Let's just multiply it by 4 and come up with the moles of our HF gas. There. And that sort of makes sense. 4 times 0.8 is about 3. So we've got moles of HF gas, we've got N, we've got T, we've got pressure, we can find V. Now you could flip to the equation sheet, or I hope you've got it memorized already, because we've used it so often, and say, okay, gas laws, we know PV equals nRT. Right, and you can calculate, we've got our gas constant, R, 0.08206. Remember, we use this, not the one that's involved with energy. We've got a temperature, we've got a moles, we've got a pressure, we can calculate. But there's an extra equation here. An ideal gas at STP, they tell you how many liters per mole. This is the ideal gas at STP conversion. And if you're lucky enough to have equation, a situation where the temperature is 0 Celsius, 273 K, and the pressure is 1 atmosphere, that's standard temperature and pressure. You can just use that 22.4. So we could go to our calculator and do times 22.4. Fast, easy. We had moles of HF. We know that there are 22.4 liters for every mole at standard temperature and pressure. That gives us a nice volume instantly. So be sharp. Whenever you do a gas law problem, make sure that you check to see if it is a standard temperature and pressure. Otherwise, you've got to use the PV equals nRT, which is a little bit longer, but save yourself a few seconds. In this case, we're just going to go and say our moles of HF times 22.4 liters per mole, and we have our 22.6 liters of hydrogen fluoride. Make sure you answer the question. Calculate the number of liters of gas measured. There, we've answered it. Now, as I said, you could have used the PV equals nRT, which is quite a bit messier. But, by the way, you might be able to guess that 0.08206 times 273 is going to give you 22.4, and you'd be right. Either way is going to give you the answer, but you should be on the lookout for shortcuts. And the STP is easy enough to remember. 1 point is awarded for the moles of HF, so make sure you do that calculation. That's nice, getting that moles of HF. Stoichiometry, 1 point for finding the number of liters of gas. Hope you did it the easy way with the 22.4 liters, and you've get, so far, 3 points for this problem. Will the pH of the solution increase, decrease, or remain the same during the course of the reaction, and justify? pH is the H plus concentration, or H3O plus, the hydronium ion. So let's go back and look at the equation. Here we've got a weak acid, boric acid, the bane of cockroaches, because it's really a very effective cockroach poison. And it changes into the hydronium ion, which is a strong acid. So we're producing H3O plus, more H3O plus. Now be careful. Remember, we're dealing with a negative log. As you get more H3O plus, the pH decreases. A pH of 1 has more H3O plus than a pH of 7. So our answer will be, we've got our equation. I've got that there. You don't have to write the equation. pH will decrease. And be very careful when you're asking about pHs, because it's sort of the opposite of what you'd expect. Low pH, high H3O plus, H plus concentration. So answer the question. pH will decrease. Yeah, that's the point, but you need to justify. Now, justify isn't explain. Justify just says, what reason did you have for this? You don't have to go through all sorts of fancy stuff and show the calculations and everything else. No, just say it is a weak acid turned into a strong acid. H3O plus increase will decrease the pH. In fact, just saying H3O plus will decrease the pH is all you need. Justifications are short. If you're writing more than 2 sentences for a justification, you're doing something wrong. You're spending too much time. 1 point earned for the correct choice and justification. You got to do both. Answer the question. pH, justify. We're at a good start. Let's go on to B.